All right, in this slide, we will use certain vectors A, B, C, and D and make some quite interesting experiment. And then we will formulate our observation to find alternative way to calculate dot product. So look at those four vectors. Well, I'm picking those four vectors because we know the angle between them. So vector D is horizontal, and vector A is 1 comma square root 3, B is 1 comma 1, C is square root 3 comma 1. So let me draw those vectors. And the point is, we know the angle between two vectors. Well, you can think of equilateral triangle. Equilateral triangle with base along this vector D. If this triangle has side 2, then one side, one of the triangle is exactly along this vector A. Or you can use trig function value to see this angle is 60. So this angle is 60. Okay, and then vector D is 1 comma 1. Sorry, vector B is 1 comma 1. Now that this is diagonal of unit square, this angle is 45. And another vector is C. This vector C and then D has angle which is 30. Well, this is square root 3 and 1. Well, you can take right triangle where this vector C is exactly the hypotenuse of the triangle, and that triangle exactly half of the equilateral triangle. So you see this angle is 30. All right, anyway, we have vectors so that we know the angle between them. So now that we know the angles between them, we are ready to calculate dot product. So dot product of A and D. Okay, let us first calculate the dot product between A and D. So this vector A has a magnitude 2, and horizontal vector D has a magnitude 2, and cosine 60, which is 1/2. After canceling, this dot product is 2. Good. And then dot product between B and D. This vector B has magnitude square root 2, and vector D has magnitude 2, and the angle between them is 45, cosine 45. So after canceling and simplifying, we have dot product. And then dot product between C and D. Vector C has magnitude 2, and then the angle between them is 30, square root 3 over 2. So after canceling, this is 2 square root 3. So far, so good. So the point is, we are using some specific vectors so that we know magnitude and angles between them. On the other hand, you can take component-wise product and then add them up. So for first two vectors A and D, vector A has coordinate 1 comma square root 3, and vector D has coordinate 2, 0. So what we are going to do is to take product, component-wise product. We have 1 and 2. So 1 times 2. For the second component, we have square root 3 times 0, and we add them up. Am I clear with what we are doing? So you take component-wise product, and then you add them up. Then this is 2. So somehow we made some calculation from vector A and D, and the result happens to be the same result of this dot product. it's quite interesting. For the second pair, B and D, vector B has coordinate 1, 1. So you take component-wise product, 1 times 2, and then 1 times 0. Again, this result is exactly same to the dot product of two vectors. Do you think it's just a coincidence? Let's check the last pair. Vector C has coordinates square root 3 and 1. Vector D has 2, 0. And again, square root 3 times 2 plus 1 times 0. The result is exactly same to the dot product of C and D. It turns out that this sum of component-wise products happen to be same to the dot product. So this gives us alternative way to calculate dot product. So let us formulate this in the next slide. All right. So as we observed, we can calculate dot product if we know coordinates. So suppose you have vector A, A1, A2, and vector B, B1, B2. Then we can calculate the dot product. So dot product is, well, you take sum of component-wise products. You take first components A1 and A2, A1 and B1. You take product, and then you use second component A2, B2. You simply add them up, then you will get the dot product. So this alternative way of calculating dot product gives us how to calculate angle between them. Suppose you have vectors, say A and another vector B with an angle theta. Okay, by definition, dot product is magnitude, and then angle, cosine theta. Once you solve this for cosine theta, then we have nice formula. So let me write this in the next line. Cosine theta is, well, if you solve this for cosine theta, we have dot product over magnitude. That's it. Whenever you have two vectors with angle theta, cosine theta is given by this formula. So quick example, let's use this formula to find angle between two vectors. Okay, in example 6, we have two vectors 1, 2 and 4, 3. So from this formula, cosine is dot product of two vectors 1, 2 dot 4, 3 over magnitude. Well, for this dot product, we use the alternative way to calculate this dot product. So sum of component-wise product, 1 times 4, 2 times 3, over magnitude. The magnitude of the first guy is square root 5, and then magnitude of this vector is 5. So if added 4 and 6, we have 10 over 5 square root 5. After simplifying, you can also rationalize. So we have 2 square root 5 over 5. Okay, so we have cosine value. Well, if you are if you want, you can use calculator to find approximation of this angle theta. So, for example, you can use arc cosine, inverse cosine, and you can use this value to find approximation of this angle.